Hello everyone. Today let's solve the problem 155 min stack. So I can just go through the question and you can just go through the example as well. So I'll just summarize the question so that it will be easier to understand, right? So first thing is what the question states here. We need to design a special type of stack that supports 4 operations mainly. So again I'm telling we need to design a special type of stack that supports 4 operations, nothing but push, pop, top and get min. So what does push do here? Push, we are adding an element to the top of the stack. Again I'm telling this one is important. Push, it adds an element to the top of the stack. Pop, we are removing the top element from the stack. Top, what does top does here? We retrieve the top element without removing it. Again I'm telling this is important. What does top does here? We are retrieving the top element without removing it. So the final one is get min. We are retrieving the minimum element in the stack in the constant time. So this is fine, right? So we are designing a special type of stack that supports the 4 operations: push, pop, top and get min. So let's initially let's discuss this example, the first example, whatever the example that they have given. Then let's go with the approach, edge cases and finally write the code and discuss the complexities, right? So initially let me remove this one. This looks odd actually. Yeah, let me remove this one. Let me make this clean. Just give me a second here. So just they have given the return values. They had mentioned the return values. That's it, right? Here. So we are considering the input, this one, the input that has been given in the example, right? First one here, min stack we are considering. So operation, we are going with the min stack of the empty, this one, right? Empty braces. So empty bracket. So what we'll do here? So first, the operation is min stack here, right? Operation that we are going here is min stack. So here we are initializing the min stack object. This one we will consider this one. This is main stack here. And let me give here minimum stack. I'll just consider minness. This one also, let me initialize this one. This is nothing but min stack. So the output will be, initially it's just the initialization. The output will be null here. So they had mentioned this one, void, right? The return value will be void, nothing but the output will be null here. So let's come to the second thing here. This one, push of -2. Let's consider this one now. Let me come here. This one here, we are considering the operation push of the number -2 they have given here, right? This one push of -2. Let me consider here. So what we are doing here, we are adding -2 to the main stack. This one, we are adding -2 to the main stack. Now S will be -2. And this one, we are also adding the -2 to the minimum stack as well. This one minus will be -2 as well, right? So the return value is void as they had mentioned, and the output will be still null itself here. So this is fine. So let's move on with the next one. I'll just come here. So we are considering this one now, push of 0, this one, right? So here, let me come here, the third one. The operation that we are considering here is push of 0, right? So we are considering push of 0 here. What we'll do here, we will add 0 to the main stack. We already have -2. Now we already have the -2 here. You can clearly see here. As main stack we are having -2 and min stack we are having -2. Now this will be, main stack will be -2 comma 0, and we are adding the smaller of 0 at the top of the stack of minness, nothing but the -2. Now here the minimum stack will be the smallest of 0 and minus 2 is nothing but minus 2 here, right? So we are considering minus 2 and minus 2. I hope this is clear why we got minus 2 here instead of 0 to the min stack. We are adding the smaller of 0 and the top of the minness, nothing but minus 2. Minus 2 and 0 comma minus 2, that one will be minus 2 itself, right? So this is what we are doing here. So the output will be still null here because the push the return value of push is they have given void, so the output will be still null here. Let's move on with the fourth operation. Let me come here, let me consider this one now. Push, we had considered 0 here, push of minus 3 this time, right? I'll just come here, fourth one, let me consider here operation. This will be push of minus 4 here. Minus 3 or minus 4? Sorry, this one has to be minus 3 right here. So just give me a second here. This will be minus 3. So let me come here. Just give me a second here. So we are adding minus 3 to the stack. We already have minus 2 and 0. Now let's add minus 2, 0 and minus 3. So this will be, we are adding minus 3 to the main stack, right? This will be minus 2, 0 and minus 3. So we are adding the smaller of minus 3 and the top of the minness, nothing but minus 2. Now the smaller of minus 2 and minus 3, it will be minus 3. So this will be minus 2. We are already having minus 2 and minus 2. And the smaller thing, the smaller value of minus 2 and minus 3, we will be adding minus 3, right? So we are adding the smaller of minus 3 and top of minus, minimum stack, nothing but minus 2. Nothing but minimum stack will be minus 2, and minus 3. Still, we know that the this one, a return value will be, return value of pushes is still this one. What do we call? Void. Then the output will be still null here. Yeah, the output will be still null. So let's come to the so what is this? So, sorry, this one I didn't delete, I think. So this is fine. We had stopped at the fourth operation, right? Let's move on with the fifth operation. This one, get min. So let me come here. Just give me a second here. Get min of empty braces, right? So I'll just come here. Fifth one. This one operation, let me consider get min of this one empty bracket. Just get min, right? So this will be, I can just consider this one. Just give me a second here. So what we'll do here, we will return the top of the minimum stack. So nothing but the minimum stack dot length minus 1 here, this one. Min stack, we are just returning the top of the minimum stack, right? This will be minimum stack length minus 1 here. Nothing but here we can clearly see minus 3. Minus 2, and minus 3. We are just returning the top of the min stack, right? The top of the min stack is nothing but minus 3 here. So here I'll just come. This will be minus 3. The last element, right? The last element, I mean the last index. The element that is present at the last index. This will be minus 3. The sixth operation, let's move on with the sixth operation. Nothing but this one, get pop of this one empty, this one, right? So let me empty bracket. So let me come here. This will be operation pop. So what we will do here, we have to remove the top of both stacks, that is main stack and the minimum stack. So main stack, we have this one. We are removing the top of the both stacks, nothing but -3 and -3. Both -3 will be removing here. This will be -2, 0 and -2, -2, right? I'll just come here. This one stack will be, we are just removing the top of the both stacks. So this will be -2, 0 and minimum stack will be -2, -2. I hope this is clear. So we know that the push and pop, the return value is void. Nothing but here the output will be null itself, right? So let's move on with the seventh operation. So I'll just come here. Sorry, this one, seventh one, top. We are considering top. This one, empty array, right? So I'll just come here. Operation. Let me consider here top. So I'll just come here. We have to return the top of the main stack, right? Top of the main stack is nothing but s of s dot length -1. This is equal to 0. This is nothing. Just ignore this one. S of s dot length -1, that is equal to 0. So the output will be here 0, right? So I hope this is clear. We are just returning the top of the main stack. Top of the main stack is 0 now. After this operation, we know here, we can clearly see here. Now the top of the main stack is 0 here. That's what we are returning here. Top of the main stack is 0, right? So the output will be 0 here. The final operation, let's come to the final step. Nothing but this one, get min of this one. So I'll just come here. Operation, let me give here get min here. This is fine. So this is fine. Get min. Yeah, we are just returning the top of the minimum stack. We are returning the top of the main stack here. For this one, get minimum, we are returning the this one, top of the minimum stack here. What is the top of the minimum stack here? -2, right? So this will be min of minimum stack dot length -1, last element, index, the element present in the last index, nothing but -2 here. So the output will be -2 here, right? So the final output would be here. Let's consider this one, null, and null, 4 nulls, right? 4 null, -3 null, 0 and -2 here. So the final output here is null, null, -3 null, finally 0 and -2. This is how we got the output, this output. So next, let's discuss let's discuss the approach, then let's discuss all the edge cases one by one, then let's write the code and discuss the complexities as well, right? So let's discuss the approach step by step. So to achieve the constant time operation for the get min, we'll be making use of the two stacks. We'll go with the approach dual stack in common terms, right? So we'll be making use of the this will be used as primary stack or the main stack. So we know this already. We have considered the example, right? So this one, previously I had explained the example. So we considered the primary stack or the main stack and the min stack. Primary stack or the main stack and the min stack. This one will be min. Yes. So this is fine. And let's discuss the this one approach step by step. For push operation, let's consider the push operation first. So we will push the value into the main stack. Push value to main stack, nothing but yes here. And also we are pushing the smaller value between the current value and the top of the min stack into the minness, right? So we are pushing the smaller value. Just remember, we are just pushing the smaller value to min stack. Nothing but min is, right? So next thing is we are going with the pop operation. So here we are removing the top element from both main stack and the minimum stack. So remove value from main stack, nothing but S, and min stack, nothing but min S we have considered, right? This one. So let's move on with the third step. Nothing but the top operation we are considering. So and I'll just give here top. So on top, what we are doing here, we are returning the top element from the main stack. Return top element from the main stack, nothing but S here. So I hope this is clear. Let's move on with the final step in the approach, nothing but the get min operation here. So let me give here get min operation, the final one. So here what we will do in the get min operation, we will return the top element of minimum stack, which always holds the minimum value. So this is important, right? We are just returning the top element of minimum stack here. I hope this is clear, right? So this is the approach that we'll be going with. Let's discuss the edge cases one by one and then let's write the code. Here, let's go with the edge cases one by one. Let me come here. Let's go with the edge cases one by one. So let's go with the first edge case, nothing but the empty stack here. First one here, empty stack. We are going with the empty stack, right? Let's go with the operations, nothing but here, pop. This will be null, right? The return value is null, and push. Initially, this will be, sorry, this has to be not push basically. Pop, this will be top actually. Top, this will be null as well or undefined. And this will be get min. So this will not be null actually. This will be undefined basically. This will be undefined as well. So and this get min, this will be undefined as well for the empty stack initially. So this is for the empty stack because it handles the operations on an empty stack without breaking, right? So these three will be undefined. So next, move on with the next edge case, nothing but the increasing order. So while I say increasing order, let me consider here push. Let me consider 1 and again let's consider push 2 here and push of 3 here, right? So this is of the increasing order. You can clearly see get min here, get min, the output will be 1, right? And minimum and the pop and the get min here, this will be 1 as well here. We are removing the or we are popping the top of the stack, right? That is nothing but the 1 here. So the minimum remains the first pushed element, right? So we know this one. Let's go with the third edge case, nothing but all elements are same. So let's go with all elements are same here. When I say all elements are same, I'm just considering here push of 5 same elements, right? Same element. So we are considering 5 here. So here let me consider get min. This one output will be 5 here. So we have the same element, right? So the minimum element will be 5 and the pop and get min as well. Here pop get min. This one will be 5 as well. So the minimum remains constant when all the elements are same, right? That is the reason we are getting the output 5 and 5. So here let's move on with the fourth edge case. Nothing but decreasing order. We have already considered for the increasing order, right? So let's go with the edge case decreasing order. Let me consider here push of 3, push of 2, and push of 1 here. This is fine. And get min will be here again, minimum value will be 1. So the output will be 1 here, and the pop this one, and get min this one will be here, output will be 2 here. Why? Because the minimum updates dynamically as smaller elements are pushed and removed. That is the reason we are getting the output 2 for this one. So again I'm telling the minimum updates dynamically as smaller elements are pushed and removed. And finally let's move on with the last edge case. Nothing but here random order operations. Random order operations. This is fine. So let me consider some random numbers here. Let me consider 5 and push off any number, right? 1 I'll consider. Let me consider 3, something, right? This is fine. And get min will be here, minimum value. This will be 1 again. So here pop and get min will also be 1 here. Comma. Get min here it will be 1. So why it will be 1 here? The minimum reflects the smallest value among the current elements here. So that is the reason the output will be 1 and 1 here. So we have discussed for the this one empty stack. We have discussed for the increasing order. We have discussed for the all elements, considering all the elements as same. And we have discussed for the decreasing order of the elements, and we have discussed for the random order operations, right? I hope all the edge cases are clear. Let's start writing the code, and I'll explain the code while writing the code itself. So let's start writing the code here. This is the they have defined the main stack class here, right? So let's define the main stack to hold the elements first. I'll just give here. We have already discussed this one. This should be easy. This one. We are defining the main stack to hold the elements. Also, we need to define the stack to track the minimum values as well, right? We have considered min s. So this one. This is it for the main class. So the second one will be a push operation. So let's add the value to the main stack. We should add the value to the main stack right here. Let's make use of the push here and pass the value here. Val is the parameter here, right? Let's pass the value here. And the second thing is we have to add the minimum value so far to the minimum stack as well. So how can we do that? I'll just consider here min val, and let me give here if min dot length, right? Let's consider length. Then we can, I am just going with the ternary operator here. Mat.min, let's make use of the mat.min and minimum stack of last element. This one will be this dot minimum stack dot length minus 1, last index, the element present in the last index. We saw this one in the example already, right? And also I had explained this one in the approach. Else will be just displaying the value, right? And finally we have to push the minimum value. For that I'll just consider this dot minimum stack. Let's make use of the push operation and let's push the min val that we have considered here. So let me paste this one over here. I hope the this one push operation is clear. Next let's move on to the pop operation. Here we have to remove the top element from the both stacks, right? So while explaining the approach that I have said, for the pop operation we have to remove the top element from both stacks. Both stacks means main stack and the min stack. This is simple. This dot s dot pop, and the next one is this dot min stack dot pop. This is fair. Let's move on with the next one. So next one, it's for the top operation. For the top operation, what we were doing basically, we were returning the top element of the main stack. If you remember during the approach, also while I took the example, I explained this one. We have to return the top element of the main stack, not the min stack. Min stack we are not considering here at all. We just have to return the top element of the main stack. I'll just come here. Let's return. We are considering the main stack, nothing but s right here. The last element presented the main stack. So this s dot length minus 1. So this is it. Let's come to the final one. Nothing but the get min operation. Get min operation, if you remember, we have to return the top element of the min stack. For this top operation, we were returning the top element of the main stack. Here we will return the top element of the min stack, nothing but the minimum value, right? So this is simple. This is similar to the previous one, right? So this one will be, instead of this dot yes min stack, we will be going with the minimum stack. Same thing, I should have copy pasted and made necessary changes. This is fine. This dot, instead of main stack, will be going with the minimum stack or length minus 1, nothing but the last element, right? The index of the last element, right? Length minus 1. So this is fine. So let me format this one and let me hit the run button. So you can clearly see the sample test cases are getting passed here. So let me hit the submit now. So all the test cases are getting passed here. So the code works absolutely correct. So let's quickly discuss the time complexity and the space complexity. So what will be the time complexity here? The time complexity here would be big O of 1. Why the time complexity here is big O of 1? We are making use of the direct stack operations. We can clearly see we are making use of the direct stack operations, right? So for all the operations, push, pop, top and get min, the overall time complexity would be big O of 1 itself. So overall time complexity here will be big O of 1. And what will be the space complexity here? The overall space complexity here will be big O of n. Why the space complexity here is big O of n and not the big O of 1 here? Because we know that n is the number of elements in the stack. So while I say n is number of elements in the stack, we are maintaining two stacks. We can clearly see here. One is the main stack and one is the minimum stack. So the overall space complexity would be big O of n, where n is nothing but the number of elements in the stack. I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.